This is lesson 1.2 for our Pre-Calc 11 class. Unit 1 is called Radicals and Rational Exponents. Lesson 2 is called Rational Decimals. In this lesson we're going to talk about, we'll refresh our memory on how to determine if a decimal number is rational, but really we're going to focus on how to write rational decimals as a fraction. If you recall, there's two things to look for that will tell you if a decimal number is rational. One, if it's a terminating decimal, and two, if it's a repeating decimal. If it's a terminating decimal, that means that at some point the numbers stop, like 0.8. A repeating decimal would be a non-terminating decimal, but it's a decimal that just continues with a pattern. Like a simple pattern like 1, 1, 1, 1, 1, or 1, 8, 1, 8, 1, 8, 1, 8. If it's a terminating or repeating decimal, then we can write it as a fraction. So writing terminating decimals as a fraction, we take the decimals, we figure out how many place values there are, and we make it that number over 1 and that many zeros. So for example, 0.354 is 3 decimal place values. So we're going to put 354 as a numerator and 1,000 as a denominator. 1,000 has 3 zeros. 3 decimal place values, 3 zeros in the denominator. 0.1 is one number, so we're going to do 1 over 10, 10 having 1 0. 85 is 2 place values, so 85 over 100, 2 zeros. And then a 6 digit, so 438,551 over a million, 6 zeros. If the question as it's asked says just write it as a fraction, there's no need to simplify it. If this was a quiz, you could get the fraction with unsimplify and get full credit. On your homework assignment, I believe the directions do say write the fraction in simplest form. If that's the case, I hope you have a calculator handy.
I have all available middle and high school staff to report to the high school kitchen to move food. Thank you, middle school and high school staff, to the foods room in the high school to move food.
I'm going to go move food with Mr. Benjamin after this. Also, more examples. If you want to write a repeating decimal as a fraction, we're going to use a little algebra. Example A, 0.4 bar, or 0.4444 repeating. We can write it as a fraction. First, we're going to let x equal 0.44444. If that's true, then 10 times x, or 10x, would be 4.44444. Again, a never-ending number of 4s after the decimal. If that's true, we could take 10x and subtract x. 10x minus x will leave us with 9x. But if 10x is 4.44444 and 1x is 0.44444, or 4 bars, and we take the difference, all the decimals will subtract and cancel out. We're left with just the 4. So what we've just shown is that 9x would be equal to 4. And of course we could solve that for x. X would be equal to 4/9. Well, x is equal to 4/9, but we've already said that x is equal to 0.4 bar. So that means that since they're both equal to x, they're both equal to each other. So 0.4 bar is equal to the fraction 4/9. Similar procedure for example B. However, in B there's a repeating decimal with 2 numbers that repeats. So I'm going to say, okay, let's let 0.62 bar equal to x. 100x, if that's equal to x, then 100x would be 62.62 bar. And then if I take 100x and subtract x, I get 99x. But then also 62.62 bar minus 0.62 bar. Well, the 62 bar would cancel out, or the 62 forever, minus 62 forever, like those would equally cancel each other out. We would just be left with 62. And therefore, 99x would be equal to 62. And we can figure from that x is equal to 62 over 99. Well, if x is equal to 0.62 bar, and x is equal to the fraction 62 over 99, then 0.62 bar must be equal to the fraction 62 over 99. Okay, one more repeating decimal example. In this one, we have a 0.3, and then we have 5 bar. So there's a decimal 3, but only the 5 is repeating. We can do the same procedure with just one extra step at the end. So we're going to let x equal our original decimal, and we're going to let 10x equal 3.5 bar. And we're going to take 10x and subtract x. We get 9x, 3.5 bar, or as I wrote it here, 3.55 bar. And we subtract 0.35 bar. The 5 bars will cancel out. 5 minus 3 is 2. Got our decimal. And then 3 minus 0 is 3. So then we're going to be left with 3.2. And so 9x equals 3.2. Let's see here. So then we can say, okay, if that's true, then we can solve for x. X would be 3.2 divided by 9. Now, for a fraction, we don't want to have a decimal as a numerator or a denominator. So what we're going to do is just multiply both by 10. So we're going to get 32 over 90. And that would be a fraction that equals our repeating decimal. Again, this isn't fully simplifying, so read the directions carefully to see what they want you to answer, or how they want you to answer. Takeaways: we can take any rational decimal and turn it into a fraction. And with a little help of algebra, that makes that possible. So thank you, algebra, for being useful, I think.